Alright, so here's a physics problem that I did on position, velocity, and acceleration. And in this problem, we're going to try to find the acceleration of a man driving his truck. So the problem goes, a man is driving his truck down a long straight road. At 3:15 p.m., he is at a position of 13 meters per second. Oh, I'm sorry, at a position of 13 meters in the x direction. He's traveling with a velocity of 24 meters per second. And then at 3:30 p.m., he's at a position of 8,000 meters in the x position. So within the time he was driving, what is his acceleration? So for here, we're going to write down our knowns. So our first position is 13 meters. Our second position is 8,000 meters, both in the x direction. Our first velocity is 24 meters per second. Now we don't have our second velocity, so we're going to use a different formula to find just the acceleration. So the final velocity isn't needed because what it's saying is at 3:30 he's at a position of this, but he's still traveling. So he's not at a zero position. At a zero velocity to end. So our change in time is 15 minutes. So 3:30 minus 3:15 is 15 minutes. And so we're going to multiply that times 60 to get 900 seconds. So we converted the minutes to seconds. So then we come down here, and the formula is your final position equals your first position plus your first velocity times your change in time plus half of the acceleration times your time squared, your change in time squared again. So what we need to do is we need to get A, which is the acceleration by itself. So we work some algebra out to finally get A down here by itself. Well, to do that, you're going to multiply your 2 over, just figure your algebra out, work it down. So what you should get at the end is your 2 times your second position minus your first position minus your velocity over your change in time. So if you take all of your knowns up here and you plug them in for this equation, you should get your acceleration equals the 2 times your second position, which was your 8,000 meters, minus your 13 meters, which was your first position, minus your 24 meters per second, which is your velocity from up here. And all of that's going to be divided by 900 seconds, which was your change in your time. And you should come out with your acceleration within that time period that he was in to be your 17.7 meters per second squared. And that is how you figure it out with only having the first velocity and a certain amount of time that he traveled in.